Hi everyone. In this tutorial, I'm going to go through orientation constraints, so constraining the geometry based on a particular angle. So this will be useful for getting the aggregation to work through different view corridors that we can then relate it to things like solar data and view data in conjunction, say, with an external context of the city. So for this tutorial, I'm going to be using 007 files in the studio content. So straight off the bat, we'll see that basically we've got our component here. It's a bit more of a detailed component, but generally the setup of the connection logics should still apply. The key difference in terms of Grasshopper is instead of normally using, I'm going to full screen this, instead of normally using the basic part component in Wasp, we're actually going to be using the Wasp advanced part. And so this allows us to do a few different things. So we still need connections, geometry, name. We've got some other things like collision geometry, fields, hierarchy, attributes, which is also in the basic. But the main one we'll be looking at today is this orientation constraint. So this will be using an angle to define the orientation of the aggregation. So what we want to do is we want to set this up the same way we would normally, where we define the connection logics and component geometry and connection points. You'll notice when I'm doing it here now, I'm making sure that I've got a basic component still that I'm working with just as a basis for the connection points, because we want to make sure that all the connection lines and surface points are on the surface of the geometry. So this all is basically the same, and same with the rules. I will note as well, like other tutorials, that it still is going to rely heavily on the rules. So you're still going to need to slightly calibrate the angle and the rules that you're applying. Ideally, you'll do this kind of later in the semester when you've found a component geometry that you're happy with and found connection logics and rules that you know will give you something interesting. So we're going to be using also a boundary constraint. So I'm just using a kind of bounding box like this, where I'm just moving the geometry into the center of the bounding box. So looking into the angle constraint, you can see here we've got a kind of viewing angle. And so what we need to do is we need to go into Wasp and go to the constraints tab, and we can use a Wasp orientation constraint. And so that needs a couple of things. It needs a direction of the part orientation to be tested. So within this component, we're going to need also another direction line. And this direction line basically gives the algorithm an understanding into which direction we're testing. So if I go dir, we're going to be testing this direction. So architecturally speaking here, if I'm kind of, inside this module, I want to be looking outwards, right? So my direction line is the same. I want the direction to be testing looking outwards out of this window. So that's one information that we need to give the orientation constraint component. The next is the range of angle that we want to test, basically. So to do this, we basically set up a domain. So a domain is just a numerical value or range where we can specify all the values between, say, negative 102 and 153 to test. And so that's our range of angles. And so we can visualize this range through this part here, where it's going to basically show us the angle that we're testing. So from this center point, this is the kind of range where the building can look into. So this all gets fed into the orientation constraint part here. Other than that, it's basically then the same. We set up our rules, we make sure the mode is on 3, number of parts, and then we can just click run, and I'm going to just turn this on now. And so we can see it's now kind of testing the orientation, and it's giving us some sort of interesting orientations. It's trying to fit it within here. So if I start to change this angle, and maybe let's make it say 70, and I press reset, you'll see now, based on those rules and this angle, it's going to give me this kind of aggregation where basically everything's stacked, because it's all kind of looking at this direction. So we don't necessarily want something like this. We want to just try to search for particular angles of aggregation that we can find. So you can see now, the reason why there's a window here is because I've got a window at the back. But if I just look purely from the front perspective, you can see that all these windows, if I'm in this kind of window here, I should be able to have a view corridor in this range. And similarly here. So this is a great way of basically being able to define certain orientations of your aggregation. And in a later tutorial, I'll show you how to build this up with say another type of script where, say, we do first an aggregation where we're just aggregating blocks, and then from there we can then load the aggregation back in and aggregate based on this orientation. But you can see we're getting some sort of, you know, interesting movement within the kind of architecture. Go back. Of the tower, and if I keep adding to this, hopefully we can get some sort of nice kind of aggregations happening. So these are kind of, this is a way of really engaging with the context. So you can imagine now, if I had, say, surrounding context where I've got, you know, buildings and buildings. Here, I probably don't want the views to necessarily be directly looking into this building. So I might want to change the view corridor to be more something like, let's just go back into shaded mode. Say something like this. So this can get a bit slow depending on how many components you have. So I'm just going to bump this down for now. And then we'll just change this now. There we go. So now if we bump this back up to 1,000. So now we can see here, this is what basically, if we were to start designing a tower, where we want, say, all the apartments to have some kind of view, we can see most of this aggregation is happening looking outwards, but then we've got to resolve this part, which we'll go into in a separate tutorial. But you can see how this is useful then to start to play with view corridors within a city context. And then finally, what we can also do is, like we've discussed in previous tutorials, is visualize that those connection logics that we're creating, which is helpful for us to understand on a more abstract and basic level what the aggregation is looking like. So obviously you can see, there's this big kind of problem here with the angling of the aggregation that we need to resolve. But this is a good way of, like I said, understanding how views can affect the aggregation. So if I were to keep continuing to aggregate this geometry, what I might do is I might go back and look at the rules that I'm setting up for myself, and understand exactly what rules do I need to implement further to maybe allow for more orientation to the views. Because at the moment, if I just grab these, the rules that I'm using, and we see, this, I'm only using 6 rules, and so this might not be enough. I might need to start to include more rules into the aggregation so that it allows for more possibilities of orientation, for the relationship between the orientation constraint and the rules to occur. So that's something to keep in mind. So it's really going to be a back and forth between setting up the angle of the view relative to some context or some local data of sun, and then also the rules that you have in place, and then obviously also the design of your component. So maybe, when I do it, I might also want to have windows on this face as well, which in the next tutorial we will go through how to do that. So that's that tutorial. In the next tutorial, I'll go through some of these things that I've mentioned, including solar analysis and mapping in more detail, kind of different types of components within a aggregation. Thanks.